Welcome to myprojectbazaar.com. Our project title is Node Scheduling Control inspired by Epidemic Theory for Data Dissemination in Wireless Sensor Actuator Networks with Delay Constraints. Now see the abstract. Generally, a wireless sensor network consists of spatially distributed autonomous sensors. Most of the wireless sensor networks consist of static sensors, which can be deployed in a wide environment for monitoring applications. While performing data transmission through multiple hops become less reliable. The sensor nodes broadcast their status to the surroundings and receive status from other nodes to detect each other. Recently, actuator nodes that perform diverse tasks have been introduced, and the sensors and the actuators can form a network which is called a wireless sensor actuator network. In this network, sensors gather information from the surrounding environment, while the actuators perform appropriate actions on the environment. The desired level of performance under dynamic environment is difficulty data dissemination, packet routing, and broadcasting of wireless sensor networks. Also, sensor data should be valid at the time of action, since actions are performed on the environment after sensing occurs. Therefore, an efficient and reliable data dissemination scheme is essential in order for the actuators to act responsively and accurately. Hence, the system proposed an adaptive dissemination rate control scheme according to the delay requirements of applications, which results in dynamic adjustment of information spread rate. In order to conserve energy while meeting the delay requirement, the proposed system formulates node scheduling model that determines the state of each node in the network. Through the mathematical analysis, behavior of the algorithm in terms of converge time and steady time can be predicted. The simulation results indicates that the proposed scheme outperforms the existing approaches in terms of its matrices like delay, energy, and the delivery ratio. Let's see the flow of our process. First, the network is constructed with the number of sensors and the actuator nodes within the communication range. Then, the nodes generates packets to forward to the destination. For that, the duty cycling process is executed. This process includes the scheduling algorithm, and this algorithm generates the control timer. This is nothing but the wake-up timer for each and every node in the network. After the timer is generated, the mode of transmission is executed. The mode of transmission includes active and the sleep mode for all nodes in the network. After that, the channel availability is verified. If the channel is ideal, means it transmits packets, else it waits in the queue and again performs the duty cycling process till another wake-up timer is generated. Then it process these steps again. After the packet transmission, it performs the analysis process. In this, the proposed system is compared with the existing system. Let's see the output demo of our project. Open the terminal window and go to the directory where we have the code. Then type ns space file name .tcl. Here 120 nodes are created in the network, and these are all the neighbors of each and every node with its distance are calculated here. For each and every node, the neighbor nodes is find out and the distance is find out by its x position and its y position. After it completes running, we get the output results in the network animator window. Now the animator window opens. Open this window. These are all the sensor nodes that deployed in the transmission range. Like a video, we have to play the simulation. Now the sensor nodes are represented in green color and the other color nodes are the actuator nodes. This is the simulation time and this is the speed button. Now the dark green color nodes are represents the active nodes in the network. So other nodes are in sleep mode. Now this represents the transmission of all active nodes in the network. So here each and every active nodes transfers packets to its destination by finding its neighbors. To multiple hop it transfers packets. Now the timer is end. So these are all done by the scheduling model. So according to the scheduling, the packet transmission is performed here. At another simulation time, here all nodes are going to sleep, and again according to the wake up timer process, the other nodes are activated. These nodes are randomly generated according to the wake up scheduling algorithm. So now it again transfers packets in this slot of scheduling. After the transmission ends, we can see the performance in the graph. So here now this slot is end. So again another slot is activated and it performs the communication. Like that all packets transfers successfully, and when this timer is stopped, it again goes to the sleep state. Now the transmission becomes finished. So we see the graph result. Back to the terminal window and type xgraph space graph name. This is the energy graph dot xg. This is the energy graph. Here the energy is idle, so it does not increase highly. Suppose the system minimizes energy consumption, that is, it becomes ideal. So now to see the another graph, type xgraph delay.xg. This is the delay graph of our proposed system. Delay is varied according to the scheduling process. Thanks for listening.